Thanks for the introduction. Thanks for having me. My name is Tobias Weinzierl, as I said, from Durham University. And I will tell you something about a project which has just about started. So many of these things are forward-looking. As I said, this is one of the new DRI projects that we have. And I want to do something you shouldn't do in a talk, also not in a lecture. I'm going to give you a quick background of what I'm interested in, but then I will start with a story of frustration. So it's a negative example. And I think this will set the tone. No, it shouldn't set the tone for the remainder of the talk, but I will give you an idea where I'm coming from. So I'm a scientific computing guy. Most of the stuff that I do at the moment are about simulating binary black hole mergers and doing seismic simulations, so earthquakes. We do tsunamis used by landslides, do a little bit of classic CFD planes. So that is kind of the areas where I make a contribution. And to be quite honest, I have no clue of these things, okay? Because this is not what I bring to these consortia that I'm working with. What I'm interested in is I produce the tools that allow these researchers to do their job. I have an image on the next slide in a second. So what does that mean? My group does research around adaptive mesh refinement. That is kind of what I've been doing for 20 years plus. I love to do research around linear algebra, very special case, multigrid algorithms. So for example, we do a project with Eike Müller from Bath. That is something I'm interested in. I'm interested in tasking as a programming paradigm. Okay. That is work we started with Excalibur. We continue to do that with colleagues from Intel. I'm interested in compilers, domain-specific languages. That's work I do here with Nick, and so forth and so forth. So I'm really interested in getting the tools up. And what this means is I've built my career writing software, a few dedicated pieces of software. So, and now I tell you a story of utter frustration either earlier this year or end of the next year. So this is, to the left is not frustration. That's one of my former PhD students. That is kind of the type of simulation, so a binary black hole merger. That is what I really like, okay? That is stuff I don't produce. I enable other people to produce it, and I'm proud of that. So now here's my story from earlier this year, and I checked before. The people who were in that meeting are not here, so I can diss them without being overly careful. So that was a big consortium that met and was kind of a wrap-up meeting. And there was a really nice chap standing here on stage, a junior colleague, and he told us, he gave one of these standard scientific talks, okay, 1 out of 20 on that day, 15 minutes each. And he said, yeah, I ported that part of that big physics code onto a GPU cluster, and carried on. And I thought throughout the talk, I've been there. And then, yeah, I think I've read a paper recently about this issue, and so forth and so forth. And the guy closed his talk and said, and now we run on Grace Hopper, and we are now 2.5 faster than on our CPU system. And then I made an error. I raised my hand and said, isn't that disappointing? And never do that. I got really talked down in front of the whole group, not by the speaker, because the speaker afterwards approached me in the coffee break and said, you're right, by the PI. And the PI said, you should know better than me how difficult it is, and that this particular application domain doesn't fit onto GPUs at all, but we had to do that due to political reasons, and we had to use Grace hoppers because they go into Bristol, and everybody now has to use Grace hoppers, and so forth, and basically told me that I'm totally wrong. So after that, in the coffee break, I approached the RSE in that case, or PDRA, RSE, and I said, yeah, I apologize. I didn't, I just observed, and it was really an honest question. Is 2.5 disappointing if you switch to a GPU? And he said, yeah, you're totally right. And then he basically gave me the story, what happened behind the scenes. And I think this is very archetypical. So that guy was sent by his group to Edinburgh for a CUDA course, 5 days. And after that, by definition, that person was the expert on GPU programming in the whole group, which meant all the others continued to write their code actually on a different branch and said, well, and this guy then eventually will port it onto a GPU. Okay. This guy was given some kind of consumer hardware. Yeah, and then once you go to the Grace Hoppers, it will all fly. Okay. This guy, as I said, had to continue to work on his branch because all the cool physics happened in other branches. And then, yeah, we're gonna merge that eventually. And I think I'm really think that is kind of archetypical. It happens quite a lot. And I find it very frustrating. And as I told you, my career is built on these tools. So that hurts. I don't want that. Okay. So I think it is an all-time classic. Very often we deliver our GPU ports very, very late. Okay. The performance is not what we actually want to get out. And finally, a lot of these things are reinvented. I mean, it's really frustrating if you see that someone working 2.5 years on the GPU port of a major physics code and not a single paper about what they actually have done in terms of computer science. Okay. Well, after 2.5 years, they probably then publish in the domain science. That's important, but nothing methodological, not even a comparison to what other groups have done in that field, because believe it or not, a lot of groups have started to port their codes onto GPUs. So I don't want that. And yeah, how do we fix that? And then there was this call on by DRI, by the DRI program, can you do an accelerate computing hub? And I thought about that, and then actually Mark contacted me and said, yeah, you should bid. Okay, and we came up with a bit, and this is kind of the high-level description. We call it the thing sharing. To be honest, that is probably, yeah, we always need a nice acronym, okay? So we converge, Alan, we converge on that one. Eventually, it's a UK-wide initiative to accelerate research by combining faster hardware, smarter methods, and skilled people. So basically all the things I would have loved to see in that example that I just sketched. It focuses on research technology professionals. That for us means RSEs, platforms experts, it means PhD students, PDRAs. And then there is two people who are often left out, and I don't think that's very clever. It means academics and it means managers. We can come back to that later on. Yeah, and it's about empowering people. So that is all blurb. I'm pretty sure no one has an idea what we are actually doing. So Mark sent all these people my way, and then we built up a consortium, and then I collected all the informations, and most of them were academics. That meant I have 10 academics in the Zoom call, at least 11 opinions of what this grant should actually do. I decided that I want to have this, okay? I want that people pick the right machine, the right tool, and the right code for their science, okay? And it doesn't always to have the latest, biggest GPU, exascale, whatever machine. It has to be the right one. So that's the goal. And then people, to achieve that, people have to have the right skills to go there. Yeah, come back to that in a second. And then if they have the right skills and they know what kind of code they want to have at which machine, they still need an environment, an ecosystem where they can do these things. Okay, as I said, we had a lot of people who are very interested. It's interesting, the very moment you start to write a bit, there's a lot of people who tell you what should be in that bit, as long as they don't have to write it and get something out of it. So I got a lot of very constructive emails. And then I said, no, 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 no. So what we don't want to do is we don't want to do performance engineering, code tuning. That is not the ambition of sharing. There is other programs for that already, and they do a good job. So we don't want to replicate that. We also didn't want to focus only on RSEs. So I had a couple of people who approached me and said, oh, I have this grand big code and it runs there and there. whenever someone starts a conversation pointing out in how many European Union projects this code is used, you know exactly where it ends up. Can you give us more money for development? And we said, no, we don't do that, okay? I don't want to take this grant and split it into 10 pieces, and then everybody goes away, and after 2.5 years, they come back with a 2.5 speed up. Okay, so that was the first thing. No, no, no. No, no. Second one, we didn't want to reinvent training. There's really no short. How many people know of their home institution that they have a CUDA introductory course? Okay, I see a couple of hands up. There is no shortage of yet another CUDA intro course. Okay, so we don't need that. It's all out there. There's no need to reinvent that. So I don't want to do that. And I had people who said, yeah, but I am the big dedicated expert in GPU programming and I can teach that. Yeah, that's fair enough, but then we don't need this program to support that. By the way, the same, we didn't want to focus on GPUs only. It's called accelerate computing, which is way wider, okay? It's not only about GPUs, it's other accelerators, but for us, it also covers the whole spectrum. So again, we said, no, no. Then I had the standard thing, can we buy some kit? No, that was not the idea that you buy yet another small GPU cluster. There Again, that's not the idea. Oh yeah, and then we had, oh yeah, we are big. We can consult other people on, give them our expertise to port their codes. That is not what people need. I mean, people want to do that themselves. They want to deliver their GPU code. They really don't need an external expert who tells them what to do. For this, you have professors, okay? They know exactly, they tell you all the time what you have to do. So no, no, no. And on that upbeat, I managed to prune the consortium dramatically. Okay, so they went away and joined other bits. Some of them successful, some of them are now coming back and want money nevertheless, but that's a different story. Okay, so we got that down. So so now you know what we do and what we don't do. So this is what we ended up. I'm pretty sure I've gotten someone. So I'm Durham University. In Durham University, it's mainly computer science and advanced research computing. But we have members from physics, and I also have a second hat. I'm the director of the Institute for Data Science. So this is in Durham, the things participating, and then we have Cardiff, Queen Mary, COSAC, and so forth and so forth. So these are our partners that we have at the moment. Okay, so let's dive a little bit. That's a slide that's pretty full. If you take these 3 boxes, if that's the takeaway, that's sufficient. Okay, and I'm gonna run through the text, and we will come back to these motives over and over again. So an ideal world, what would be an ideal world for accelerate computing from my point of view? And the first one is performance and machine assessment. So in an ideal world, I think as a PI or a small enterprise or whatever, I can take a piece of code and I have some place to go to and ask the people, can you tell me what you think about that code? And can you maybe make a recommendation what kind of system in the UK would be the right one to look at? Or what kind of hardware on the market would be the right one to have a look? So something like an assessment service, that would be really, really useful, okay? Would also be pretty demotivating in a lot of cases, but that's life, okay? Someone tells me, yeah, you don't have to think about GPUs, fix your memory, whatever, access patterns. Well, that's a message as well. So this is the questions we want to answer. Is the code well suited for acceleration? Is there a potential for performance gains? What platform fits best? Okay, and it could be, well, you're very, very heavy on floating point 64, so you don't have to look in some of the new generations of accelerators. That's fine. So we need that kind of information. So well-informed decisions. And to do that, we need a methodology, how to do these assessments first. So that is the first big pillar. In an ideal world, this would kind of where actually projects start. And then we have to do the actual work. And that means we need training. Training means training on performance assessment, obviously. It means training on some code development that includes programming, but also profiling, debugging, all of these things, version control, all these skills that we need every day. But that's all technical. Besides that, we also need a lot of better professional skills. Project management, I will come back to that later on. Okay, at the moment, it's all pretty ad hoc what we do, which I find surprising personally, but I can't fix it. We need certain communication skills. As I said, speaking to academics is notoriously difficult. Okay, so there's certain professional skills here. We need certain leadership skills. Things like procurement is certainly very important if you think about bringing in your own system because you have this use case, code use case, and all of that has to be a mix. Okay, curation, what material is out there, and filling in gaps. As I said, reinventing the wheel should not be something we should not spend our resources. Okay, so that's the training part. And then finally, you need the right ecosystem. So something like a test bed overview, where are the systems that I can play around with? What are their properties? What networks are out there that I can dip into and I can benefit from? And then all the events, workshops that we kind of expect such a hub to pioneer and lead. So those are the three pillars. And I want to dive into some of them. I just said we started, so officially we started early summer last year when the grant letters and things came in was later last summer and then the summer break. So not all of that has started already, but some of it has started. For some of them we already have stuff. So I'll zoom into those details now. And there's one thing you probably can't read. Well, you can read it on the back. At the bottom, it says this whole thing also has to be delivered in a coherent way, and it should be delivered in an accelerated, fast way. Okay, just waiting for 2.5, 3 years, and then hurrah, here we are. I mean, by that time, I hope not, but it might happen that quantum works. Okay, or anything of these things. So we might be late again. Okay, so next one. Let's zoom into that assessment thing because that's something I kind of understand. Okay, it's kind of an area where I think I have something. I know what's going on. Okay, so assessments for us. We want to do in-depth studies of code and machine behavior. I already said that. We want to understand how certain codes behave, where there is potential, what machines are the right one. So said that. Okay, so that's really what we want to do. As I said, the code development is nothing we really cover. Now, that's not 100% true. Sometimes you have to play around with your code. You have to trial a few things to get an understanding why a machine handles certain cases particularly well and others not at all. But that is a different thing than using a big production code and adding new features or porting some compute kernels onto HIP because you already have a CUDA port. Okay, that is the kind of things we don't want to support. There's other resources for that. Okay, and the final benchmarks here for that rubric has to be, does the whole assessment as we do these assessments feed into Sharing's vision? Can we produce something that is relevant for broader audience? Okay, it is not only relevant for the 10 users of that code, but for a broader audience. And does it plug back into other work packages? And I think we can do that. Now, this is absolutely plagiarism, or when I wrote it, okay? I wrote that part and I didn't invent it because there is already such things. And so let's phrase that way. I got inspired. So there is people who do that for a living. Probably the most important one for me is the POP. Has anybody here ever used POP? Okay, so one person here, 2, 3. So POP is a European Center of Excellence. Okay, and what they offer, well, now they offer it again to us, but there was a time where we were not allowed to bid, and you all know why that is. So what POP offers you, you submit your code and they analyze your code. And then they send it back and they ping pong it forth and back with the developer. And they give you a nice 10-pager, 20-pager at the end of the day that tells you exactly why your code runs particularly good on a Euro HPC machine or not. It's very, very useful. My own code ran through a couple of these POP assessments. I found it extremely useful. So that exists. POP is very, very tightly tied to the VAHPS consortium, which stands for Virtual Institute for High Productivity. I should know that. I'm a member of that consortium. I don't know what the S stands for. So you can look it up. So anyway, this is tool developers, okay? This is the people who develop tools like Scalaska and Jülich. RWTH Aachen is in there. Barcelona Supercomputing Center is big in there. So you give your code to them. They throw all of their tools onto it. They extract metrics from the machine, give you an assessment. So that is really, really, really useful. And I would like to have something like that for the UK, for accelerators. And maybe slightly different. So that is one example that we have. The other thing you probably, well, you guys all have gone through CIUK, okay? At the time when it was still called Machine Evaluation Workshop, and then for a couple of generations after that, there is these Machine Evaluation Workshop reports where Martin basically breaks on. That's another example of kind of a performance assessment. Whenever you do bid for Euro HPC machine resources, and that holds for most, I guess, does it hold for Dirac as well? You have to run through a technical assessment. Yeah, okay. So somebody does actually an assessment of your code. How in-depth that is a different question. Okay, but in principle, there is a lot of expertise out there of people who do that. And then this basically comes back to the research allocation panels to make a decision. Oh, and finally, a lot of supercomputing papers spend a lot of time in performance assessment and evaluating machines. To be quite honest, in supercomputing, a lot of the papers are methodologically not that grand, you know. They get through because they use a new piece of kit that no one has looked at before. And that is very useful information. So that means people have knowledge, they know how to do that. So what we have to ask ourselves, can we use that for the UK community? And for me, that means a lot. Do we get the right level? I said, I'm a big fan of POP, but I can't do it because it requires an in-depth understanding of all these performance counters. Okay, it also requires the right machines. You need root accesses and things like that. So it's really made, the assessment workflow is made by experts in tool development who then apply that onto codes. We probably need something a little bit different, something that's simpler, where we can start from the code. The next thing is most of these assessments are traditionally tied to one machine because you ask for resources on one machine, or you ask for Euro HPC for particular machines, okay? What we want to have for sharing is something that says, well, we look at the characteristics and we kind of think you really should look here, and you might look at this machine and maybe this cluster. So that kind. And then finally, also all these assessments are traditionally extremely simulation heavy, because that's where, so two of my best postdocs left for AMD, unfortunately. I know that they do exactly these assessments for machine learning workflows, okay? But in academia, I have the feeling that this assessment is predominantly done in the simulation business. So again, we might have to look whether we cover the whole range of applications. Okay, so we have done some stuff. We have work started. We have some ideas what high-level analysis guidelines can look like. So you get these spiderweb diagrams, okay, which normalize it, where you see, okay, we are good in that metric, we're good, not that good there. We are in the process, I don't think they're online already. We have first spreadsheets, Jupyter notebooks, okay, where you can basically type in data you have measured, and it gives you, it summarizes, it creates this reporting. We have a workshop on the afternoon of the 7th of November. I'm not sure whether it's already up there, where we bring in different people who present what kind of assessment they deliver, okay, what these typically look like to dial it. So we have started some work there. And we also, so this year was the first time where Durham is one out of 4 partners who sets a challenge in the ramp up to CIUK. So we tried, when we designed our challenge, we tried to get this assessment nuance in there, okay? So we don't want just students telling us that they used -03 and then did code ran fast. We want students to explain why they see certain behavior with code. So that is first work we've done here in that work package. Okay. When you want to realize that, when you want to assess your code, you have to know where the test beds are. Okay? So what we would like to do in sharing is we want to curate an overview of test beds that is very much inspired by Excalibur, where you can look up where a lot of these test beds had been funded and you can browse through them. So we want to do that. And again, the question for us is, what information is actually important to the audience? And to be quite honest, the vendor doesn't, that's not relevant. But there is other things that you need to know at this point. Why might this be worth looking at? And yeah, what information is important for predictions? What might this mean for certain code characteristics? And then again, when we assess this work, does it fit to Sharing's vision? Does it increase the uptake? I don't know about you guys, but in Durham we have quite an extensive set of test beds, and I think somebody could sit down if we had more time and create a hype cycle where you see that once the system comes in, the uptake is massive, but then it also goes down quite rapidly. And I think it is important that we create such overview and we get the overall the usage of the test beds up. Again, do we feed into other work packages, and is this of relevance for the wider community? I said there is existing work. I just said this Excalibur, the HNES pages. I don't know whether they're still maintained, but at least they're still there. So you can look it up. We know that a lot of the different sites have test beds. We know that vendors provide a lot of their stuff in the cloud. So we are aware of that. I think what we have to ask in sharing, what information is really relevant for the user? How can people add their test beds to such an overview? How do we keep the data in from up to date? And how do we search in a systematic way? Okay, if I'm asked, can you look at this code? How do I make decision at which platforms you look? So technical training, that might be interesting to a lot of people here as well. So we want to create content, we want to run events, and we want to support learning pathways. But I think for this, we have to answer a couple of questions, okay? We don't want to reinvent the wheel. So what we have to do, we have to get a feeling of what content is missing in the current landscape. And as I can just say this over and over again, yet another CUDA course is not missing. I'm pretty sure about that, but I'm not 100% sure what is exactly missing, but I have some ideas. Try to find good tutorials on how to set up containers, and the number of information already becomes, there's not that much out. So there are certain things there, okay? We don't know what didactic approaches are best suited. A lot of the things, how we train, is still pre-COVID. Okay, so in-person workshops. I don't know about you, but I'm increasingly frustrated of the number of participants showing up compared to the registrations. Sometimes we fly in external speakers and then we have 2 people in the room, where we kept the number of participants at 25 or whatever. That is totally frustrating. So we have to rethink how we deliver training and how we get people engaged. Yeah, and as I said, what communities are left out? Is there certain people, managers, platforms, experts, where there is not that much? So we have to find that out. And I think then sharing wants to get an overview, again, with accelerator glasses on. And then we have this ambition to contribute, to make our contribution to missing building blocks. But it has to extend the current ecosystem. Okay, I already said that. Every university have their own training program, vendors have their own one. I understood EPCC, SSI, DRAC. There's other DRI initiatives, okay, who all create training. All the European centers have a lot of training out there, and I think we want to complement that and maybe integrate that into our vision but not replicated. Okay, we have done, work has started, so you will find that on the sharing platform. So we have another project which is called High End, which got funded last summer, where we promised that we bring tool developers together with developers. We ran a couple of these events. They were really cool. I enjoyed them, besides the fact that not that many people showed up as had registered, but that's a different topic. I really enjoyed the sessions with the tool developers. So we had Lenaro in, the Scalaska guys, Cedric Valenci with Macau. Intel was in with VTune. So we had a couple of people who came, who dropped by and pitched, and those were all people who were very close to the tool. And what I found out at one of the sessions, I had a chat with I don't tell you where this person is from, but it's a was a PDRA in physics. And we had in the evening in the pub, we had a conversation, and she said, that was really cool and really exciting. What the heck is a cache? Okay, so what we did is we started as part of that. We have now started to do these small roadmaps, very fundamental ideas, because you cannot expect everybody to know all the jargon. Okay, but you have to be prepared that if people don't know things, but you want them to benefit from, for example, tools in our case, that they have a place where they can go and just look up small lectures. So snippets like that, and I think this is really cool. You can find it on the sharing webpage, and we really have the intention to get more of these 15 minutes, 20-minute snippets where you can just look up things, so you can then benefit from all the events and all the stuff that we put online in a better way. Okay. Yeah, so we are currently working on a C++ lecture series. I'm horrified that a lot of departments kick out compiled languages, okay, in their curriculum. I don't know about your place, but in Durham, I think only computer science still teaches C++ as part of the undergrad. That's a catastrophe. We have no shortage of Python programmers, but if you ask someone about really hardcore compute kernels, it's very difficult to find PhD students in that area. So what we did is we are now working on a small C++ lecture series, where you get up to speed very, very quickly. And we have a couple of other things that we are working for. At the end of the day, we are a little bit blocked there. We wait for the first assessments to see what kind of skills are missing for people who want to run assessments, and then we can again fill those gaps. But we have made, at least we've done something already. Okay, skills. I said that. Skills, this is really the area where I'm really unsure what skills are missing. I am aware, I mean, Alan is sitting there with the N8 DRI retreat, so there is certain things happening. I'm not sure what kind of material we have to provide on the long term. By the way, I tried to find a picture where I am on the DRI webpage. I didn't find one, which I find annoying. I found one with my wife who has the same family name, so that's good. But next year, please, I would like to have a picture of me on the webpage as well. Okay, cool. So I said there is a couple of things already offered in the UK. We have to look what is specific to accelerate computing and what kind of material do you want to curate. Okay. We have ideas on professional skills, okay? So we want to collaborate with other initiatives. There's a lot of really interesting work going on. So for example, we had conversations with the SSI, which I found extremely interesting, where I learned a lot. We are preparing questionnaires. There's a couple of ideas floating around in the consortium that I hadn't been aware. So for example, to which degree is our technical writing of reports for when you look at codes up to speed, and what can we do there? We use sharing also. Yeah. I'm really, really horrified how alone I felt when I got the grant. Oh, yeah, now I have to implement it. How do I do that? Okay. And there's nothing like in a lot of our scientific computing HPC projects, there is no guideline. This is how you run a project. Well, at least I'm not aware. If you know, please tell me after, but not in front of the audience in the coffee break, okay? Please tell me afterwards how to run these big projects. What I've decided so far is that I use sharing as my own guinea pig and playground. I used to be a big fan of extreme programming. Now I'm not at all anymore. Okay. But I decided let's use a few ideas of this agile programming and try them out, whether we can use it, because agile programs are changing requirements, changing teams, quick delivery cycles. These are all things that I want to have for sharing. Okay, so let's try out a few of these ideas that we have there for code development and apply them to the consortium. Okay, this is just my repetition. Now let's have a look how that actually works in practice. So in sharing, we have working groups. I will give you an overview of the individual working groups, but more or less they map onto those three big regions. And these working groups are chatterboxes, okay? So people meet, we now meet all on Teams because we don't have Zoom anymore, but they meet on Teams and they come up with these ideas. Oh, wouldn't it be great to have that? Wouldn't it be great to have that? Wouldn't it be great to have that? And what we do in sharing is that the briefing is very clear. These things, shouldn't we do that in sharing, lead to small tasks. Task is something that we call probably lasts a month, 2, 3 at most, small building blocks. This is kind of a sprint idea from XP. So they define that and they feed it back into the consortium where we collect all of these different ideas. Oh, we should do that on training and we should look at this particular code. And we need this for the machinery and we need a new document that describes the assessment. I can give you some examples later on, but this is the idea. So working groups define tasks. They go back to the consortium where we all look at them and we look whether the tasks align with sharing's overarching vision. So once the consortium comes to the decision that this is a cool idea, we issue bids. So we say, well, this task really should be done. Who wants to do that? And that is where we rely a lot on the RTPs in the consortium. They say, yeah, this is something I find really cool. Can I do that? So we have a bidding mechanism. It's lightweight, but it's kind of RTPs bid for funds to realize some of the tasks that the working groups have identified. Our vision is on the long term that the advisory board ranks them similar to a customer in XP, an external customer. We are still in the process of setting that one up. So at the moment, there's the steering board who basically ranks the bids, and then we commission them. So we hand out the tasks, and once they're complete, they feed back into the working group, and then naturally they unlock usually follow-up tasks. Does this make sense? So it's a very agile one. There is no big master plan in that sense where we have 50 different small work items and then we split them up and institution A does 1 to 10 and institution B does 11 to 20. We don't do that. It's really these tasks are identified as we run. Yeah, and then the feedback I said that. Okay, so this is another thing how you can write that down. Okay, so this workflow. What was the goal? Maybe to give you an explanation because it looks horribly complicated. I think it is horribly complicated to a certain degree. But what we didn't want to do is this the winner takes it all mentality. Okay, where you have 3 consortia bidding, 2 of them win because there were 2 awards made. Each of them has 5 participants. They split up the money. And then every institution has 2 people working on it for 3 years. And then at the end, we look what comes out. I didn't want that. I didn't want that. Oh, no, I wanted to have something that is more flexible and where we can, for example, react to availability and interest of the people involved. This thing in principle is able to upscale, give me more money. Okay, so in principle, we can add more and more tasks. But we also have an external control and steering mechanism in there. So again, what I didn't want to have, and I've seen that in consortia I've been in before, you win the contract and everybody is super excited of the vision and then everybody hires a PDRA and then you just do what you have always done. And this is exactly what led us initially to the situation that people come back after. It's one of the reasons. After 3 years, you come back and you say, yeah, now it runs on the GPU. It's 2.5 faster. And you think, what did the others get out of that? What did you get? That is not the things I wanted to have. So therefore, this task mechanism. So status, where are we? So we have this process now in place. The call for this task realization at the moment is ring-fenced. I had to do that there is some legal implications here but we plan to open that up. The working groups are all set up. We will maybe next month open these working groups to a broader audience. So basically others, externals can join and can make suggestions what they would like sharing to do. And as I said, we are working on this advisory panel thing. So this is an overview of the grant. I'm not going to run into each individual sub-work package. As I said, there's working groups for each individual one. All of them identify tasks and feed it back into the central administration. But for example, here, that is performance assessment. It breaks down into a working group, which looks what kind of codes should we study, what areas shall we cover, what kind of methodologies should we cover. There is a second working group which looks at different methodologies. There's a third one which looks at the accelerator overview and landing pages and search pages. Second one, technical training. And then there is one on professional skills. And then as everybody, we also have an outreach and capacity building work package where we also want to see whether we can get small and medium enterprises into that overall vision to share it. All right, so why does it matter? Maybe you see I'm coming to an end. I think I have 4 more minutes if my... Okay, cool. So why does it matter? Okay, we have this chasm, okay? There is research codes over there, and then we have the accelerators over there. To be quite honest, we didn't want them, okay? Industry gave us GPUs. Now we have to live with it. And we want to deal with that. We want to bring that together. And for this, I think we need performance assessments to evaluate and understand what we have been given. Okay, we will never design our own chips in the HPC simulation community. We have to deal with what's on the table, but for this, we need a solid understanding of what's going on. We think there is a skills gap, both on the technical side and on the professional skills side. By the way, it is not only a skills gap on, for example, people who realize code. There's also a massive skills gap, for example, on the academic side, where they have certain ideas of what software developers should give them in projects and what they should do. Okay, so there's a lot of training to be done there upwards in that direction. So we want to create new content where needed and curate existing one. At the moment, we have, I think in the UK, this is something I really like. We have quite a diverse ecosystem when it comes to test beds. It's incredibly difficult to navigate it. So this is something where we want to build bridges and homogenize things. This is really something that's very close to my heart. I want to know where to search and how to get access and how to look at things. And yeah, I think this whole business, people who work in that area are not supported and appreciated in the way we would like them to be appreciated. And I have some ideas why this is. This is one of the next slides. Okay, as I said, those are the 3 work packages in the first strand that are already live. And as I said, there will be calls for people to join in if you want to steer the direction of travel. So these are 3 people. So performance assessment methodology, and test beds. We have the technical training, which is currently led by Ed. There we decided to fuse 2 work packages of the original bit. Eva here, who by the way is responsible for the design, because if I would do the slide design, it would look quite crappy. So she organizes she looks at the professional skills, or she coordinates that working group and summarizes their outcomes. And then we have, I have no picture of Chris. Okay, I have to change that. So we have started to do the industry outreach and dissemination work package. We also we started the community outreach, but I discuss that in a moment. Okay, so that is where we are with sharing. Let me try to wrap that up and do a few things. What is key performance indicators? Obviously, I would love to get my code better, but that is unfortunately not covered by sharing, so bad luck for me. What I would like to have in the near future, it would be really, really cool if, for example, all the research allocation bits from the UK are successful, at least on the technical side, if they have run through sharing. You know, that's kind of the things I would like to see. Informed data-driven decisions, why certain bits are successful, why certain bits should get access to machinery. That would be really, really cool. Short term, we can do that. Right hardware for the right science. I mean, I don't know how many people of you have been involved in university procurement. What I get in terms of requests of new academic staff, they all need now a Grace Hopper under their desk for development. I don't understand it, okay? They don't even know how to install that thing or what this thing does. But they just read somewhere that this is now the coolest thing, and by definition, their research is excellent, and therefore they need such a chip. I don't like that. I think we should really have, that's a part, you know, there is ecological and economic reasons for that. We should use the right machine for the right science, and I really want to get there. Yes, and better software development strategies that is tied to them. In the midterm future, I would like to see publications. I'm quite honest about that. We complain a lot about the lack of appreciation of the whole HPC business at universities, and there is initiatives which challenge existing KPIs, things like the hidden ref, and I think they are very, very important. But to a certain degree, we also have to admit that we kind of know the environment we work in, and we should, in our business, try to make a contribution there. And one of the contributions that we can make, and we don't, well, at least projects I've seen, don't do that in the way they should do, is write papers, write down why you have done certain things, what you have found out, what are the lessons learned. This, by the way, unfortunately means you also have to read papers, okay? And that is something we're also not very good at. So I want to see publications. I think there is a big potential here for impact stories, okay? If we do it in the right way. Yes, and I said another key performance indicator, if you want, is do we manage to get more people into sharing than only the core consortium? We have to start somewhere. We even have to ring fence, as I said, the funding for the first year or so, but we want to get more people involved. We have collaborators. These are not all collaborators, but these are 4 that are very, very important to the realization. I start on the right, Durham University. So we are involved in 4 DRI projects at the moment. And I'm very happy that all 4 of them feed into sharing in one way or the other. We have colleagues from COSAC in there, which is incredibly important because they cover now quite a wide range of applications. That helps us a lot. I'm very thankful to DIRAC in particular. Claire said, yeah, oh, there is Claire. She said, yeah, it's absolutely fine. We can give you support to host your content and give you support. That is important. It's really important. And you're going to hear from Nick sitting over there at the front, likely still working on his slides. He will present Cake. We want to do a lot of outreach, community engagement. And again, it makes no sense to reinvent that. There's a dedicated DRI project for that. So we decide. So I always say sharing is piece of the cake. So I want to engage with that one. But what you also realize that there is a lot of blank space in there. And I would really hope that this slide has completely changed in a year's time and we have more really, really good collaborations with other initiatives. Those are the ones that are active. We have conversations with other ones, but this is something where something is happening already. Okay, this is time for an advert. I have to do that, sorry about that. For parts of these conversations always kicked off or continued at the HPC days. Maybe you block that in your calendar. That's the week before ISC. And I think we will have great conversations there. And I hope that I can present you some sharing success stories there. I've said that. No, let me go there. I said this. Right, pick the right machine, right tool, right code for the science. I can summarize it in a different way. faster delivery of faster science workflows using faster sharing building blocks. That's basically it. That is sharing. And yeah, thanks a lot for your attention. I hope we have a great conference. I'm pretty sure we have. And yeah.
All right. Thank you, Tobias. Great opening keynote. Thank you very much for your time and presentation. We are also streaming online, so I have a few questions from the online audience before I go to here in person. The first one is, are there any sharing prospects to expand beyond UK borders to consider an international arena and any room for collaboration outside the current borders?
So the funding is UK funding. Okay, so they will stay here. But I mentioned before, we have these links to Euro HPC, and I think this is the thing we really should dip into now. I would love to have more collaborations under the umbrella of the Euro HPC joint undertaking program. I would really love to have more collaborations in that space. So we can't promise that, but we would really love to do that, in particular in Europe. Outside of Europe, I'm happy to investigate, but it's more difficult, obviously, because I'm not aware of any framework.
So the next question is, how about FPGA-based HPC acceleration platforms, which are used in the edge computing applications? Do you target those as well?
Yes. So that is one of the things I said. It's accelerated computing. It is not GPU. This was one of the people who dropped out when we made it clear multiple times. No, it's not only GPUs. No, it's not it's not only GPUs. Yes, FPGAs are important. Smart network controllers are examples. I think Edge AI is super interesting. And again, you need the right hardware for every single business case. And I'm a big fan of super computing, okay, the big machines. That is where my scientific heart is. For a lot of use cases, that's overkill. And I think they're better advised of actually looking into FPGAs, look into RISC-V, look into outside of the traditional CUDA type architecture plus x86 universe.
Thank you. Any questions here? Yes, sir.
Thanks for a very interesting talk and thought-provoking. And I'm preempting my common question a little bit by saying I'm putting my foot in here deliberately. When I was listening to your talk, first I got excited and thought, that's interesting. Then I thought, hang on a second, you are repeating what is already there. And I give you two examples. At one point, you basically said, oh, we are doing things different from the RSE, but you actually described what RSE is supposed to do. I thought, why? Another point, which I think is a little bit more important, you said, oh, POP is very good, but I want to have something similar, but not that complicated. And to be perfectly honest, the longer I was listening to it, and this is the honest part here, I thought this sounds like Excalibur to me, something which is already there, happening in Europe on a much larger scale. And because this country decided back in 2016 to do a very stupid thing, and we have to stick to it, so we have to brew our own pot here. We can't simply join them. Is it not time, and that is the provoking part, is it not time to own up and say, look, we've done shit back in 2016. It was the most stupid decision which this country has done for quite a long time. Sorry, guys, but we have to join the EU again. At least we have to collaborate. There are wonderful tools in Jülich, for example. Friends of mine are working there. Why not using these tools instead of reinventing? And I'm pretty sure a few people hate me now, but I'd rather be hated and I die with a
I don't think.
and instead of saying, okay, I just follow the political line. Thank you.
Okay, cool, thanks. Okay, I'm not going to comment on political decisions where I'm not responsible, which I'm not responsible for. Yeah, so for example, POP is a brilliant example. Have you ever used performance counters? Brilliant. Okay, excellent work. And this is exactly the point. There is no need to reinvent that. There is no need to reinvent things like PAPI or the tools that are built on top of that. This is exactly not what we do. What is way more what we want to get with sharing is we want to invite those developers over and share their insight with us. Regarding the POP methodology, we have to look at it. POP methodology at the moment is done in compute centers. We try to roll that out and let, if you want, at a not supercomputing site, use these tools, you very quickly run into real challenges because they're not easy to use. And this is something, for example, where we can add something on top, which is easier, more lightweight to use with the intention, by the way. And you certainly know that POP is now open again to us, okay? As I think autumn last year. So with the intention that people then submit to the POP assessment. So this is an example exactly where I think there is a gap and we will not replicate POP. Okay. So does that,
Any other questions? Okay. Thank you very much.
thank you very much.